Welcome to the Deep Dive. Today we're looking at a really interesting paper, Uncertainty in Action, Confidence Elicitation in Embodied Agents.
Yeah, this one's from UIUC, and it gets right into a core problem. How do AI agents, the ones operating in complex spaces like Minecraft or potentially robots, figure out how confident they should be?
Exactly. It's not just about the AI knowing something, it's about it knowing how well it knows it.
Yeah.
That's pretty critical as these systems move into more unpredictable real-world situations, right?
Absolutely critical. I mean, for those of you following machine learning, you'll know we've seen huge leaps in what AI can do, but reliability, especially in messy, dynamic environments, that's still a big hurdle. And this paper tackles a key part of that, the agent's own self-assessment. Can it gauge its confidence and, crucially, communicate it? Think about a warehouse robot.
Right.
It needs to know how sure it is about identifying that box, especially if the lighting's weird or something's blocking the view.
So our mission today is basically to unpack how they're approaching this idea of embodied confidence and what it might mean moving forward.
Let's dive in.
Okay, so at a high level, the researchers introduced this framework built around what they call elicitation policies and execution policies.
Right. So the elicitation policies, that's basically how they prompt the AI to think about its confidence. Is it looking for patterns? That's inductive reasoning.
Or applying rules.
Deductive.
Yeah. Or maybe weighing up several different possible explanations, abductive reasoning. So the prompts are tailored to the type of thinking involved.
And then the execution policies.
Those are more active. They're ways the agent can test its own confidence, maybe try out a few different actions mentally, or look at the situation again from a different angle.
Got it. And they tested all this in Minecraft, which makes sense. It's super open-ended.
Exactly. And what's really neat, I think, for you following this, is the granularity they're going for. It's not just one overall confidence score for a task.
No, they want the agent assessing confidence during perception. Like, am I seeing this right? And then also during the action or planning stage, is this the right next step?
So uncertainty could pop up anywhere, and they're trying to capture that.
Precisely. That reflects the reality of interacting with a complex world.
Okay, digging into their introduction, they really make the case for why this matters so much. They draw this parallel to humans.
Yeah, we do this constantly, right? I'm pretty sure, I'm absolutely certain. I'm not sure about that. It guides our decisions, how we interact.
And they argue pretty convincingly, I think, that for AI in autonomous driving or, say, medical support, being able to express uncertainty isn't just nice. It's fundamental for safety, for trust.
Absolutely. And they call out the specific hurdles with embodied AI, too. You've got multimodal inputs, vision, maybe PEX prompts, sensor data.
Confidence needs to work at different levels, seeing a block versus planning a whole crafting sequence.
Plus, the agent's actions change the world, which feeds back into uncertainty. And then there's the big one, the black box nature of these huge models, like the LLMs and VLMs they're using.
Right. You can't just peek inside easily and see the probability scores like you maybe could with older models.
Exactly. And that's a key challenge this paper tackles head on. If you can't easily look inside, how do you get the model to tell you how confident it is? Their answer is through clever prompting.
So moving to their related work section, they give a nod to older uncertainty methods in ML, right? Things like entropy, conformal prediction.
Yeah, but they point out, like we just said, that many of those rely on having access to the model's internals, which isn't always feasible now. They also situate their work within the boom of using LLMs for embodied agents, and specifically mention Minecraft as this key benchmark environment.
But they highlight a gap, which seems to be their main motivation.
Right. They argue there hasn't been a systematic way to figure out where the uncertainty is coming from in these agents. Is it a perception error? Or a flaw in the reasoning or planning?
That's a really good point. If an agent messes up, you need to know why to fix it, or even just to know when not to trust it. Was it seeing things wrong, or was the plan itself bad?
Exactly. Knowing the source is crucial for building more robust systems.
Okay, so let's get into the nuts and bolts of their method. It revolves around these elicitation and execution policies. You mentioned the elicitation modules target perception and action confidence.
Yeah, basically asking, how sure are you about what you see? And how sure are you about this next step or plan? And how they ask is defined by the elicitation policy.
Let's break those down. There are 5, right? Starting with vanilla.
Yeah, vanilla is just the baseline. Hey, agent, how confident are you? Straight up. Help see what the model does naturally.
Okay. Then self-intervention. That sounded interesting.
It is. It's about decoupling. First, ask the agent to generate the answer or plan. Then, in a separate prompt, ask it to evaluate its own output. The idea is to reduce bias. Maybe it's less likely to overestimate its confidence if it's evaluating after the fact.
Huh. Like taking a step back.
Yeah.
Makes sense. What about the reasoning-based ones? Chain of thought.
Right, CT. This is aimed at inductive uncertainty spotting patterns, making generalizations. The prompt pushes the agent to lay out its thinking step by step first, then assess confidence based on how solid that reasoning feels.
Okay, so linking confidence to the reasoning process itself.
Exactly. And for deductive uncertainty applying rules, they use plan and solve, or PNS.
So like figuring out crafting steps based on known recipes.
Precisely. Here, the prompt asks for an explicit plan first, then confidence scores for each step, and the overall plan's success chance. It gets at whether the rules are being applied correctly in the specific context.
And the last one, top K, for abductive uncertainty.
Yeah, that's when there could be multiple good explanations or ways forward. Top K prompts the agent to list, say, the top 3 or 5 possibilities, each with its own confidence score, forces it to consider alternatives.
Okay, so those are the elicitation policies, different ways to ask. Now, the execution policies, these are about the agent doing something to refine its confidence.
Exactly, it's more active. 3 main ones. Action sampling. The agent thinks about several different actions it could take next and evaluates them.
Kind of exploring the immediate options.
Right. Then scenario reinterpretation, looking at the current situation from different viewpoints, maybe focusing on different aspects.
A bit like getting a second opinion, but from itself.
Sorta, yeah. And finally, hypothetical reasoning. This is exploring what-if scenarios. What if this block wasn't here? What if I tried that first? Exploring counterfactual.
So it's actively probing its understanding. That feels like a significant step beyond just reporting a static confidence level.
It really is. So they tested this whole framework in Minecraft, as we said, 30 tasks, easy, medium, hard.
Yeah.
And they use 3 different agent backbones.
Right, GPT-4V.
Known for strong multimodal abilities,
MNLM.
specifically trained on Minecraft data.
That's Steve.
Which is built on Llama, also fine-tuned for Minecraft gameplay. So a good mix of generalist and specialist models.
And how do they measure how good the confidence estimates were?
They used standard calibration metrics. ECE expected calibration error basically checks if saying I'm 80% confident actually means you're right 80% of the time.
Okay.
And AURC area under the ROC curve, which measures how well the confidence score predicts whether the agent will succeed or fail. Higher AUROC means better prediction.
Gotcha. And they use some other metrics too, PRP, PRN.
Yeah, those help account for class imbalance. Maybe the agent succeeds way more often than it fails, or vice versa. They give a more nuanced view of predictive performance in those cases.
Okay, makes sense. So the million-dollar question, what did they find? What were the results?
Well, first off, even just using the elicitation policies without the active execution policies showed clear benefits. All their proposed policies improved calibration, lower ECE and failure prediction, higher AURC, compared to just the basic vanilla prompt.
So prompting matters. A lot.
Definitely. And interestingly, the structured reasoning ones, Qs and PNS, generally perform the best. Suggests that making the model think step by step really helps it gauge its uncertainty.
What about the top K one? For multiple explanations.
That one proved more challenging. Calibration wasn't as strong compared to COT and PNS. It seems like accurately judging confidence across multiple possibilities is harder for these models.
That tracks. Objective reasoning is tough. Did the underlying model matter?
Yes, significantly. They saw clear differences. GPT-4V, for instance, often showed more consistent improvements across the board. The models fine-tuned specifically on Minecraft, MNLM, and Steve sometimes struggled a bit more to generalize their confidence estimation, maybe because their training was more focused.
Interesting. So even with the same prompting, the model architecture itself plays a big role.
Absolutely. Their inherent capabilities still shine through, or perhaps their limitations.
Okay, so that was just elicitation. What happened when they added the execution policies, the active refinement?
Generally, things got even better. Adding execution policies tended to further improve both calibration and failure prediction.
Any standouts among the execution policies?
Action sampling seemed particularly helpful, especially when combined with the structured elicitation policies like COT or PNS. Thinking through concrete next steps really seemed to ground the confidence estimate.
What about the hypothetical reasoning? The what-if one?
That one was a bit mixed, actually. Sometimes it helped, but occasionally it actually degraded performance slightly.
Oh, Why might that be?
Well, the thinking is maybe exploring too many hypotheticals can sometimes introduce more confusion or uncertainty, making it harder for the agent to land on a reliable confidence score. It's a bit counterintuitive, perhaps.
Yeah, interesting trade-off. Did the ablation studies shed more light?
They did. They looked at combinations. Action sampling plus scenario reinterpretation seemed like a good, balanced combo for improvement.
But strategies involving action sampling generally did well.
Consistently, yeah. And usually, using all three execution policies together gave the overall best results, though maybe with diminishing returns compared to just using the best two.
Okay. They also look at perception versus cognition confidence, right?
Yes, this was fascinating. They compared how well confidence and perception, am I saying this right, predicted success versus confidence in the reasoning or planning. Is my plan right? Perception confidence was actually a better predictor of overall task success.
Really? Why would that be?
The hypothesis is that the perceptual part, while still complex, might be more stable or have clearer right-wrong answers within the context of the task, whereas multi-step reasoning involves more potential points of failure and compounding uncertainties.
That makes a certain kind of sense. What about repeating the execution policies, like asking the agent to refine its confidence multiple times?
They saw improvements initially. ECE got better for a few iterations, but then it tended to plateau. You hit a point of diminishing returns.
But the failure prediction, the AUROC,
That tended to keep improving with more iterations, although the gains got smaller each time. So more refinement helps predictability, but perfect calibration might be harder to achieve just by iterating.
okay, wow. So wrapping up the core findings then, for someone following this space, it seems like this paper really provides a solid framework.
It really does. It shows that how you ask an agent about its confidence, elicitation, and giving it ways to actively check itself, execution, are both super important.
And it highlights that challenges remain, especially with certain types of reasoning, like abduction, and that the underlying AI model still matters a lot.
Definitely. It's not a one-size-fits-all solution, but it's a huge step towards agents that understand their own limits.
So let's zoom out a bit, thinking about the history here. Uncertainty in AI isn't new, right? ML researchers have been working on this for ages.
Oh, absolutely. Decades of work on uncertainty quantification. But like we touched on, the game has changed quite a bit with these enormous pre-trained models, the LLMs, the VLMs, and the push towards agents acting in these really complex open worlds.
The old methods don't always fit.
Not easily, no. Many assumed you could access internal probabilities or gradients, which is often not the case, or at least not straightforward, with API-based models or just incredibly complex architectures. So this paper feels very timely. It's responding directly to the need for reliable confidence assessment in these kinds of modern AI systems.
It feels like a necessary step for safety and trust as these agents become more capable and deployed more widely.
I completely agree. It's foundational work for building AI we can actually depend on in situations where mistakes have real consequences.
All right, let's shift gears slightly to our novel notions segment. Based on everything we've discussed from this paper, what kind of future research directions jump out at you? Where could this lead?
Okay, yeah, this is the fun part, thinking ahead. One idea that struck me is the concept of maybe meta-confidence.
Meta-confidence.
Yeah, so the paper is about getting the agent itself to state its confidence. But what if we had another model whose job was specifically to evaluate how reliable the first agent's confidence statements are?
Ah, like a confidence auditor AI.
Kind of. This meta model could learn, maybe by looking at the agent's behavior, the situation, its past performance, whether the agent tends to be overconfident in certain scenarios or underconfident in others. You could potentially use techniques from things like anomaly detection. And remember how the paper found different models had different calibration levels? This meta layer could potentially help normalize that, giving you a more consistent trustworthiness score regardless of the underlying agent architecture. Imagine having a dashboard for your robot fleet.
That tells you not just what the robots think, but how much you should trust their self-assessments in that moment. That's potentially very powerful.
Right. That's one avenue. Another thought I had goes back to that finding about abductive reasoning, the top key policy being the trickiest for calibration.
Yeah, dealing with multiple possibilities.
Exactly. So maybe we could use adversarial training specifically to target that weakness. You could design scenarios, especially in a rich environment like Minecraft, where there are several very plausible but ultimately incorrect interpretations or plans alongside the single correct one.
Trying to actively fool the agent into being uncertain.
Or rather, forcing it to become much more discerning, pushing it to refine its ability to assign confidence scores more accurately when faced with ambiguity. Think about those similar-looking blocks. Again, maybe one is needed for crafting, the others look almost identical but are useless. Adversarial examples could train the agent to be less easily fooled and more nuanced in saying, okay, I think it's this one with 70% confidence, but that one is still possible at 25%.
Sharpening its judgment in ambiguous situations. That makes a lot of sense, too. Of course, disclaimer for everyone listening, these are just speculative research ideas.
Absolutely. Just brainstorming based on the paper's findings. Food for thought.
For sure. Okay, so to bring this all home for you listening, this paper, Uncertainty in Action, offers a really variable, structured way to think about and improve how embodied AI agents express uncertainty.
Yeah, the key takeaways are definitely the importance of structured prompting, the elicitation policies, and active self-assessment, the execution policies. Both matter.
And it really underscores this idea that AI understanding its own limits is just as important as its raw capability. It makes you think about what truly trustworthy AI looks like. As always, if you want to dig deeper yourself, the link to the paper's in the show notes.
Definitely worth a read if you're in this space.
And maybe a final thought to leave you with. As AI gets better at telling us when it's unsure, how does that change how we interact with it? How does transparent uncertainty reshape that human-AI collaboration, especially when the stakes are high? Something to chew on.
Deep stuff indeed.
Until our next deep dive, keep exploring.